Hello, welcome to Algebra 1, Lesson 3.4. So we've been talking about linear systems of equations, and we looked at last lesson how to solve linear system of equations through using graphing. Today we're going to get into how to use it using algebra, how to solve it using algebra. So how do you find where the two things, two lines intersect? Well, you can use algebra. So the first way for using algebra is to set the equations equal to each other. These equations that I have here up on the screen, I don't know if they look familiar to you or not, but they were the first equations that we looked at when a horse, when you were racing a horse and you needed to run faster because the horse caught up to you, right? And we solved it using graphing last time, but today we're going to solve it using algebra. And so the easiest way to solve these is going to be set them equal to each other, because you can see here that they both are equal to D. And if this is equal to D, let me put it here in a red circle. If 0.2t is equal to D, and 0.5 times t minus 6 is also equal to d, then we can just simply, one of the properties that you've learned says if a is equal to b and b is equal to c, then a is equal to c, right? If a is equal to b and b is equal to c, then a is equal to c. Because you have that common variable that they're both equal to, you can easily just say A is equal to C. So in this case, we have if A in the red is equal to B in the green, and B in the green is equal to C in the blue, then we can just put the red equation equal to the blue equation because they're both equal to D right here in green. So 0.2 T is equal to 0.5 t minus 6. Okay, so now we just solve for t. So there's nothing we can do on this side. 0.2t, that's going to stay exactly the same there. 0.2t equals, here what we need to do is distribute the distributive property. So we're going to multiply 0.5 times t, which is 0.5 t, and then we're going to multiply 0.5 times negative 6. Again, use your calculator. That's the best way to do it. 0.5 times negative 6 is going to be negative 3. There's just to double check it. We have one negative here, so our answer is going to be negative. 0.5 is the same thing as taking half of something. So half of 6 is 3. So that makes sense. But I still always want you to use your calculator, because that is the easiest way to avoid simple mistakes. Okay, so now what we need to do is get all of our variables over to the same side. So what I want to do is I'm going to take this variable right here on the right and move it to the left. And remember, if I'm going to move something to the left, if it changes sides, it needs to change signs. So I'm going to have 0.2t that stayed on the same side, so it's going to stay exactly the same. But my 0.5t is going to change sides, so it's going to go from positive to negative 0.5t. And we can do that through using the subtraction property of equality. All right, so here we have 0.2t minus 0.5t equals negative 3. Now we need to combine like terms. We have a like term here with t and t. Since those are like terms, I can go ahead and write my t down here. And then I need to combine my coefficients of 0.2 and negative 0.5. Again, I'm going to use my calculator, and I get negative 0.3t equals negative 3. So now we simply need to divide by negative 0.3 on both, oops, that's a 3, on both sides. So using my calculator, -3 divided by -0.3 is going to be 10. So t equals 10. Okay, well, we have one answer. We know what t equals. T equals 10, but we have a second variable right here, the d. We still need to figure out what d is going to equal. So how do we do that? Well, this is when we can use our substitution and substitute 10 into either one of these equations where we see a t. So I'm going to take the first equation because that's going to be a little bit easier. D equals 0.2 times 10. And I'm just going to plug that into my calculator. 0.2 open parentheses, 10 close parentheses. And that's going to give me D equals 2. D equals 2. And these are the same equations we got when we, or same values we got for T and D when we looked at the graph and we solved it via graphing. We saw that we had only gotten 2 kilometers and the horse caught up to us in 10 minutes. Here we go. I have for us the graph we used last time. So here was our solution, 10 and 2. So that's what we saw before. Another way of solving is through using substitution, which is basically what we just did when we set them equal to each other. We were substituting them both for D basically by setting them equal to each other. But in this case, what we're going to do is we're going to substitute something for either the X or the Y. And in order to do that, you have to first solve for one of the variables. You either have to have X equals or Y equals, and then you take what that equals and you substitute it in, right? So let's look at how we do this. I think I want to solve for Y, okay? So if I'm going to solve for Y, it's going to be Y equals 8 minus X. That's the same equation as this, right? I've taken my X and I've switched its side, so I had to switch its sign. Basically, I subtracted X from both sides, right? So now I have this equation, Y equals 8 minus X. So now I want to take this equation and plug it into the first equation wherever I see a Y. So I'm going to go ahead and write 3X plus 2 times, and this is where we'll plug it in, 8 minus X equals 19. And I'm going to erase this and move it over just a little bit because it was in my way. I didn't leave myself enough room. All right, so now all we do is solve for X. Since there's an X in our parentheses, we're going to have to start by distributing this 2 here. Okay, so 3X plus 2 times 8, use your calculator, okay, is 16. 2 times negative X is negative 2X equals 19. All right, I've used my distribution. Now I want to simplify by combining like terms. So I see a like term here of 3X and negative 2X. So I'm going to go ahead and write X down. And then I need to combine my coefficients. So I need to add together my coefficients. I've got a positive 3 and a negative 2. When I have different signs, I find the difference. The difference between 3 and 2 is 1. I've got an implied number 1 here. Is it positive or negative? Well, my answer will take on the value, the positive or negative, the sign of the number with the highest value. So the highest value was positive. So this is a positive X plus 16 equals 19. Okay. So now I need to get X by itself. So I need to undo what's being done to X. Well, what is being done to X? I'm adding 16 to it. So I need to subtract 16 from both sides. Okay, so using my calculator, 19 minus 16 is 3. X equals 3. Well, I've got one of my 2 variables. Remember, I'm looking for an ordered pair. So I still need to figure out what my Y is, right? because an ordered pair is where the lines intersect. That's where my answer is found. So in order to find my answer, I'm going to take this 3 and I'm going to plug it into either one of these equations. I prefer the second one in this case. So I'm going to say 3 plus y equals 8. Right here I had x plus y equals 8. I took this x equals 3 and I plugged in, I substituted in for the x, the 3. 3 plus y equals 8. Okay, so now I'm going to subtract 3 from both sides. Y equals 8 minus 3, 5. Y equals 5. Now, are we done? Well, we could be. We could hope that we got it right, or we could just double check this and make sure we got it right. So if we do 3 plus 5, what does that equal? 3 plus 5 equals 8. Okay, that one checks out. What about 3 times 3 plus 2 times 5 equals, we're looking for 19. All right, I'm going to plug it in my calculator. 3 parentheses, 3 close parentheses, plus 2 open parentheses, 5 close parentheses, enter. It equals 19. It checks out. All right, so the third way that using algebra we can solve equations is through elimination. And this is what your module focuses on. If you're following along online in the book, in the module, we're on module 3, which is unit 2B. And it encourages, it teaches solving by elimination. Now, this ends up being faster for more complex equations, so it is a good one to familiarize yourself with. So the way that elimination works is you have to find something to eliminate. Remember, if you had a 5 and you had a -5, they would cancel each other out and eliminate, become nothing. They would disappear, right? And so we're looking for a way to eliminate one of the variables, right? So in order to eliminate something with our 5 and our -5, we saw that they were exact opposites of one another. So we need to find a variable that's an exact opposite of a variable in the other equation. So we have 2 equations here, and I can see right here, I have 2 exact opposites, positive y and negative y. Those are exact opposites. So what I end up doing, the first step in elimination, is finding exact opposites. Okay, I've found some. So now I need to add these 2 equations together. So 2x plus 3x, those are like terms, right? So I can put my x right there. Combine my coefficients. 2 plus 3 is 5. Okay, now my y's, a positive y and a negative y. Well, they're going to cancel out. Equals 9 plus 16. It should be 15, but I'm going to use my calculator just to verify it. 9 plus 16. I said 15 is 24. 9 plus 16 is 24. Nope, I typed in my calculator wrong. I put 9 plus 15. 9 plus 16 is 25. All right, so 25. Now, we have a new equation, 5x equals 25. What's our goal? Do you remember what our goal is? Well, we're trying to find an ordered pair. We're trying to find out what is x and what is y. Well, we can easily from this figure out what x is going to be. Our next step is just to divide what's being multiplied by the x. Well, right now we have 5 times x, so we're going to divide both sides by by 5, and we get x equals 25 divided by 5. Using my calculator is 5. X equals 5. Now, how do we find the y? Well, we're going to find the y the exact same way that we found the y on the last problem. We're going to substitute this 5 into the place of one of the x's here and figure out what the y is that way. So I'm going to do 2 times 5 plus y equals 9. Okay, so I've got 10, that's a 10, plus y equals 9. Okay, then I need to subtract 10 from both sides. So my calculator, 9 minus 10 is -1. Y equals -1. So my answer is 5, -1. Now, am I sure about that? Have I checked my work? I have not checked my work. And I want to be sure because I like to get hundreds on my tests, right? I like to make sure that I have the right answer. So I'm going to plug this in. So 2 times x, I'm looking at this equation here, 2 times x, my x is 5, 2 times 5. Actually, you know what? I want to use this equation. And the reason I'm switching is because I use the top equation to find my y. So I'm going to just check it by using the second equation here, just to be extra sure. So I'm going to say 3 times x. 3 times x, and x is 5, minus y, which is -1. I can't subtract a negative, so it's going to become a positive, equals 16. So my calculator here, I'm going to do 3, open parentheses, 5, close parentheses, plus 1 equals 16. And you can, in your calculator, do 3 times 5 minus -1. Make sure you use the negative button. If you have a graphing calculator, you have a separate button for the negative. It is not the same as the minus sign. You'll get an error message if you try to do that many times. So you want to use your negative button. You could do it that way if you wanted to, but it did check out. I did get 16 in my calculator, so I am all set. Now, what happens if you don't have exact opposites? Remember, I said the first step when we're solving system of equations is to find an exact opposite. So I have no exact opposites here. I don't even have any even close to opposites. Everything's positive, 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 positive. So I know I'm going to have to change something. So if you remember, we can change things. Let's see, 2 plus 3 equals 5, right? We can change this entire equation by multiplying the whole thing by 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 5 is 10. Well, is our equation still true? 6 plus 4 is 10. It's still a true statement because we multiplied every single object by the 2. You can't just multiply something on one side without doing the other side. Remember, that's one of the foundational concepts when you started to learn pre-algebra, that what you do to one side, you must do to the other side. Everything has to equal out. It has to be in balance, or else you're going to mess up the equation. It's not going to be a true statement anymore. So we can actually go ahead and multiply one of these equations by something to get a term that's going to be an exact opposite. So I think I'm going to want to eliminate my y's. So in order to eliminate my y's, I'm going to multiply this second equation by, well, let's see, if this is a positive 2y and I have a y here, what would I need to multiply this y by to get the exact opposite of 2y? Well, I'd have to multiply it by -2. Okay, so I'm going to multiply this whole equation, -2 times x plus y, equals 8. Okay, I want to multiply -2 times the entire equation, not just one side of it, not just one expression, the entire equation. So I'm going to get -2x plus -2y equals 8 times -2 is -16. Okay, so you can see that I have distributed this to all 3 terms. This is my new equation. I need to add it to my first equation. My first equation is 3x plus 2y equals 19. Okay, I want to add these two equations together. So my negative 2y and my positive 2y are going to cancel out. I have like terms here, x and x. So I'm going to put that right here. Negative 2 and positive 3. Those, when I add terms, when I add the coefficients that have different signs, if they have different signs, I find the difference. The difference between 3 and 2 is 1. The number with the larger value, the answer takes that sign. So the larger value is 3. It's a positive. I have a positive 1x. So I technically don't need that 1 there. I'm just going to leave it as x. Okay. Equals negative 16 plus positive 19 is 3. X equals 3. All right. So now I have an answer just like that. It has appeared to me. I don't even have to do any division in this case. I know that my first part of my solution set is going to be 3. Now, my ordered pair is my solution set. So x equals 3. I'm looking for my y. How do I find my y? I have to plug in 3 and get my answer. So 3 plus y, I'm choosing the second equation, equals 8. Now I need to undo what's being done to the y, get y by itself in order to solve for y. So 3 plus y equals 8. I'm going to subtract 3 from both sides. 8 minus 3 is 5. Y equals 5. Are we sure about this? Let's check it. 3 times 3 plus 2 times 5 equals 19. I'm going to plug that into my calculator. 3 open parentheses, 3 close parentheses, plus 2 open parentheses, 5 close parentheses, enter, and it equaled 19. It is correct. So my solution set, my ordered pair, is x equals 3 and y equals 5. Now, if you notice, when we're working on this, we have lined up our x's together, our y's together, and our constants together. You need to have everything lined up in the proper order. This is, if you go back to the different forms of equations for linear equations, this is called standard form. Ax plus bx equals c. And this allows us to easily have everything lined up in order to add using elimination when you use this format. Okay. Now, here are all the steps written out for you. If you need to, go ahead and pause the video and you can write these in your notes, but let's go over them. We're going to make sure both equations are in standard form. That's what we just talked about. Ax plus by equals c. And this is just so that we're able to line up the like terms and be able to easily add them together. Then we need to choose a variable that we want to eliminate. Previously, all the examples we used, we were eliminating the y, but you can choose the x if that's easier. If it is not an exact opposite, you get to make it an opposite. Make it do what you want it to do. You're the boss, right? You make those numbers do what you want them to do. You get to do that by multiplying the entire equation by the appropriate number and sign, because remember, you have to have exact opposites, so one positive and one negative. Then you need to add the two equations. Sometimes you can skip this multiplication step. If it's the same number and you're just missing a sign, you can subtract the two equations, but you have to remember when you subtract, you're changing the sign of every single thing in the equation, and it's not just the one thing you're looking at, okay? All right, so one variable, the opposites, in our case, so far we've worked with the y's, will add to 0, which means they cancel out. Then you're going to solve the equation, if you need to, by dividing what's left. Sometimes you don't even need this step, like the last equation we looked at had a 1 as the coefficient, so we didn't even need to do this. Step 6, you're going to substitute the numerical value you found from step 3 into one of the original equations. I don't know why that says step 3. I copied and pasted these instructions in here. You found the answer to you found the numerical value in step 5. So it should say in step 5 into one of the original equations so you can find the value of the variable. This should say step 5. We're going to see these these instructions one other time. Hopefully I'll remember to change that on those as well. All right. Excuse me. Solving systems of equations using algebra. So I want to get into, remember there's 3 different types of answers that you can have. So far we've been looking at one solution answers. But remember there's 2 other types of answers. There's also no solutions. And there's also infinite solutions. So what does that look like? Remember, we saw with one solution, that's where the lines intersect, right? No solutions is when you have parallel lines, and infinite solutions are when the lines are on top of each other, and it looks like there's only one line. So we know graphically what these answers look like, but I want to see, well, what does this look like if we're going to solve them algebraically? All right, so we've got some ways to solve by elimination. I think what I'm going to do here, what I'm going to eliminate are my y's. I see I've got a negative y and a negative 3y. So I think I'm going to multiply this one by, let's see, if it's negative 3, I need to make this a positive 3, but it's already a negative here. So I'm going to multiply by a negative 3. And that should make this a positive 3. Okay, so let's multiply this whole thing out. Negative 3 times 2x minus y equals 4. So I'm going to distribute my negative 3. Negative 3 times 2x is negative 6x. Negative 3 times negative y is positive 3y. And negative 3 times positive 4 is negative 12. Okay, so that was my first equation. So now I want to add my second equation here. Plus 6x minus 3y equals 3. Now let's add these together. Oh, that looks like it canceled out. And that looks like it canceled out. And so we've got 0 equals negative 12 equals, and positive 3, that's going to be a negative 9. 0 equals negative 9. Let me just plug that into my calculator because this just looks really crazy. Negative 12 plus 3 equals negative 9. Okay, negative 6 plus 6. Okay, that's 0. That cancels out. Everything, yeah, I got this right. 0 equals negative 9. Well, this is going to be one of those special situations where we have no solution. 0 does not equal negative 9. I know that. That's craziness, right? So this is a case when you have no solution. When you have 2 numbers that when you did algebra, it says it should be equal to each other, but it's not. This is a no solution set. I accidentally went too far, sorry. This is a no solution set, okay? So 0 equals negative 9 is no solution. All right, so we're gonna look at the next one. Here we have 2x minus y equals 4 and 6x minus 3y equals 12. So I'm gonna do the same thing. I'm gonna multiply this one by negative 3. Okay, so negative 3 times 2x minus y equals 4. Multiply this out. Negative 3 times 2x is negative 6x. Negative 3 times negative y is a positive 3y. Negative 3 times positive 4 is a negative 12. And then I want to add my second equation plus 6x minus 3y equals 12. Okay, now let's look at this. Negative 6x and negative 6x, those cancel out again. Positive 3y and negative 3y, those cancel out again. But I've got different numbers this time in the right side of my equal sign. So I've got a negative 12 and a positive 12. I've got 0 on this side. Negative 12 and positive 12 also cancel out. So I've got a 0 on this side. So I've got 0 equals 0. And I know that 0 does, in fact, equal 0. So this is not like last time. Last time we had 0 equals -9. That is a not true statement. This is a true statement, but we have no variables. So how does this help me find the solution, X or Y? Well, in this case, when you have a true statement with no variables, then what you have is infinite solutions because these end up being the same line. So you can see the graph, the blue graph is 2x minus y equals 4. The red graph is 6x minus 3y equals 12. And they're graphed right on top of each other. It's tried to illustrate that with dashes. That's not like the dashes of the greater than or less than. That's just so you can try and see the same, that they're the same line. So this has infinite solutions. Anytime you're solving a system of equations algebraically, if you get a variable equals, you're going to have one solution, right? If you get an untrue statement, number, whatever it is, equals a different number, this is no solutions. If you get a number equals that same number, then you have infinite solutions. Okay? So those are your 3 ways of knowing. So remember, we had like 0 equals -9, and here we have 0 equals 0, and I think we had x equals 10 or something. So those are your 3 ways of knowing the 3 types of answers that you get. One solution, no solution, and infinite solutions. Now, here's the steps again. Remember, this should say step 5. So I want you to make sure we're going back. I put these back on the screen because I want to make sure you have all the steps, because we're about to pause the video and let you go and try all these answers. So make sure all of this is in your notes. Make sure every example that we have gone over is in your notes for you to go back and look at. Now, we're going to go on to practice. I want you to pause the video, solve all 4 of these equations by using elimination, and then unpause, and we'll go over them. All right, welcome back. Here we have a system of equations. Everything seems to be already in standard form, ax plus bx equals c. So I'm not concerned with step 1 here. Now I do need to identify if I have some exact opposites. I do not see any exact opposites of my variables on a problem 1. However, I do see here, these are both negative, and this is a positive, and this one's a negative. So I think what I'm going to do is just multiply this one by 2. And that will give me my exact opposite of this one. Let me see if I've got this right. 2 times -8 is going to be -16x. 2 times -6 is -12y equals 2 times +6 is going to be a +12. Now I'm just going to bring over my other equation, 16x minus 10y equals 10, and I'm adding these together. 16x and the -16x, those are going to cancel out. -10y, -12y. Just go ahead and write down my like term, and then combine my coefficients. Same sign, I'm going to combine, and they're going to keep the same sign. So 10 and 12 combined together make 22 equals 10 and 12 added together make 22. So I've got -22y equals 22. My next step is to simply divide to figure out what the variable is. So to undo what's being done to the variable. So -22y, I'm going to divide by -22. So a +22 divided by a -22. Again, I want you to use your calculator, even when it seems simple like that. 22 divided by -22 is going to be a -1. So I'm going to go ahead and put my ordered pair down here. And what is it I just solved for? Y. So that's going to go in my Y spot, -1. Y equals -1. Now I'm going to choose to plug in Y, my -1, to either of these equations. Okay, I'm going to choose the second equation. So -8x minus 6 times -1 equals 6. I've got to solve for my variable, which in this case is x. So I've got -8x, -6 times -1 is a +6 equals 6. -8x equals 0. Undo the x by dividing by -8, and x is going to still equal 0. Let's confirm that using our calculator. 0 divided by -8 is 0. It's confirmed. So I believe my answer to be 0, -1. However, I'd like to go ahead and verify that by plugging it into an equation. Since I used the bottom equation to find my second variable, I'm going to plug it into the top equation. 16 times, I'm going to do this just a little bit lower, 16 times my first variable x was 0 minus 10 times -1 equals 10. I'm going to plug that into my calculator now. 16 open parentheses, 0 close parentheses, minus 10 open parentheses, -1 close parentheses, hit enter, and I get 10. So my answer checks out. This is my answer. X equals 0, Y equals -1. All right, I'm going to change colors here. All right, x plus 2y equals 3. -3x minus 6y equals 1. I have no exact opposites here. However, if you notice, both variables have opposite signs. So I've got a 2 that's positive and a 6 that's negative in front of my y's. With my x's, I've got a +1. Remember, this is an implied +1 and a -3. So what can I multiply by? I can choose to either eliminate the y or the x's. Either one will be sufficient. I'm going to choose to eliminate the x's, and I'm going to multiply the top equation just because that's what I feel like doing. So the opposite of -3 is a +3. So I'm going to multiply by +3 here. So 3x, multiply that one, and 3 times +2 is going to be 6y equals 3 times 3 is 9. And then I'm going to add -3x minus 6y equals 1. So I'm going to add the second equation here. A +3 and a -3 are going to cancel out. +6 and -6, oh, those cancel out. And that leaves me with nothing on this side, equals 9 plus 1 is 10. 0 equals 10. What did we say if we have an untrue statement with numbers on both sides, integers on both sides? Well, this is going to have no solution. These must be parallel lines. All right, so let's move on here. We have -3x, +9x, +y, -3y. I'm not really concerned with these because I don't need to eliminate either one of those. I either need to determine if I'm going to eliminate the x or the y in one of these equations. Well, I have a negative and a positive, and also a negative and a positive. So those are usually the first things I'm going to look at. But since they're both opposites, and the only thing I need to make an opposite is going to be the number, I like, when I have a variable that's by itself, I like to multiply that. So I'm going to choose to multiply this by 3. Let's see if that's going to work for me. So I've got 3 times -3 is -9x. 3 times y is going to be a +3y. And 3 times 6 is going to be a +18. Now I want to add in the second equation. Plus 9x minus 3y equals -18. Okay, add these together. Negative 9x, positive 9x. They're going to cancel out. Positive 3y, negative 3y. Uh-oh, these are canceling out too. So I've got 0 equals 18 and negative 18. They cancel out as well. So I've got infinite solutions. Why? Because we have a true statement here at the bottom. 0 equals 0. Infinite solutions. These must be the same line. Okay. Last system of linear equations we have to solve here using elimination. And we've got negative x and negative 4x, negative 7y, negative 14y. Again, I'm not concerned with these constants over here. So I think they're both, everything's negative here. So I'm going to have to multiply something by a negative number. And again, I like to multiply the x by something. When something doesn't have a variable in front of it, it's just easy to multiply. But in my opinion, for me, that's what I prefer. You could go and multiply by a positive 2 if you wanted to, and that would get rid of that, or a negative 2, excuse me. And that would get rid of that 14y. You'd get rid of your y's. But I prefer to use the ones that do not have a coefficient. So negative 4 times negative x is positive 4x. Negative 4 times negative 7 should be 28, but I want to multiply it just to be sure. It is a positive 28. Y equals negative 4 times 14 is negative 56. All right, now I'm going to add the second equation here, plus a negative 4x minus 14y equals 28. All right, so a positive 4 and a negative 4 are going to cancel out. Then I have a positive 28 plus a negative 14 is going to be a positive 14y. The y just got carried down because it is the like variable. And then I have a negative 56 plus 28, and that's going to be a negative 28. Y is not yet by itself. So I have to take that negative 28 and divide by the positive 14. And my y is going to equal negative 2. So let's get my ordered pair ready. I know that this is going to be negative 2 because it was a y here. Okay, so now I need to substitute. I need to pick one of these equations to plug my y into. And I'm going to choose the top one. So negative x minus 7 times negative 2 equals 14. All right, negative x is going to stay the same. Negative 7 times negative 2. Negative 7 times negative 2 is going to be a positive 14. And that makes sense. There are two negatives. It's going to be a positive number, and double 7 is 14. Negative x plus 14 equals 14. Negative x equals, if we subtract 14 from both sides, we get 0. In order to undo the negative, we're going to have to multiply by negative 1. Right? So x times negative 1 is a positive 1, or divide by negative 1. Either way works. And 0 divided by negative 1 or multiplied by negative 1 is still 0. So we've got a 0 here, 0, negative 2. Well, let's plug that into our other equation to see if it works. We're going to use the second equation this time. Negative 4 times 0 minus 14 times negative 2 equals 28. I'm going to use my calculator now. Negative 4, open parentheses, 0, close parentheses, minus 14, open parentheses, negative 2, close parentheses, equals. And I got 28. It checks out. And so my answer is verified. X equals 0, Y equals negative 2. There was one solution. So the more that you do solving through elimination, the easier it will become for you. I've got a few general advice tips for you. it becomes one of the easiest methods for solving when you're given equations. So it really is just a matter of practice. When you first started tying your shoes, it was really hard when you were 2, 3 years old, but now it's so easy for you and you've got it. And it's the same with elimination. It may be a little harder at first and a little bit more challenging, but once you get it, it's going to be one of the easier ways to solve these systems, okay? Substitution is easier when you have something like what we had at the beginning, d equals 0.2t and d equaled 0.5 t minus 6. When you have something like that, substitute, take this and plug it in for that. Same as setting them equal to each other, right? You're going to have, anytime if you had something like 2x plus 5y equals 15 and x equals 2 plus y. Well, it's already set up where x equals something. You could take this and substitute it in for x. That could be easier than elimination because it's already set up to have a variable equal something for you. But generally speaking, the elimination method will be the easier route to go when you have things that are just kind of all over the place. But you do have to remember to put them in standard order. Ax plus bx equals c. Then you need to find something to eliminate and adjust as needed. So sometimes you have to multiply it. And then you substitute to find the second answer, second part of the answer. So I hope that you understood that, get that practice in. You do have an assignment to go over. And we'll see you in the next lesson.